So classification of matter, the first thing is we need to know what is matter, right? It's not what's the matter, but what is matter. So matter is anything that occupies space and has mass. So that's most everything, right? Doesn't include things like energy, though. Doesn't include like emotions or ideas. But like anything you can put a sticker on definitely is matter. We use the word substance to refer to a particular instance of matter, a particular kind of matter, right? So we could say this bench top is made of a substance. This is a particular substance, right? And the floor is made out of something else. Scientists like to classify things because it helps us to organize our thoughts and see what things are alike and what things are different. It's a lot like games that children play when they're small. You know, you're supposed to sort the blocks and you put the red ones over here and the blue ones over there. And you can take cars and you can put them into different categories. Motorized vehicles, right? Well, this one has 2 wheels and that one has 18 wheels, this one has 4 wheels. You could go by color, by what their fuel source is. There's all different ways that you can classify them. So there's different ways that we can classify matter. We can classify it according to its state, its physical form, or we can look at its composition. What is it made out of? So states of matter, the 3 states of matter are solid, liquid, and gas. And we should be fairly familiar with those. We think about water. Water in the solid form is we refer to as ice. Water in the liquid form is what we call water. And in the gas form, we would call it steam or water vapor. There's some humidity in the air, that's water in the gas state. And so we see water in all 3 states. When matter changes between states, it does so based on the temperature, right? How do you make an ice cube turn into liquid water? You heat it up, right? And you can take that water and turn it into a gas by heating it up more. So it'll change from solid to liquid to gas. We can also learn or look at the relationship between the particles. So this isn't water, but it's there's the train. Yeah, you listen to the lecture videos, and it's like, oh yeah, train has to put in its opinions. Some green atom there. In a solid, all of those atoms are really close together, and they're not moving relative to each other. And so a solid is going to have the same shape and the same volume. It doesn't matter what kind of a container you put it in. In a liquid, those atoms are still or molecules are still very close together, but now they can slide around. So you pour water into a different container and it takes on a different shape. The volume's the same though. So solid has a constant volume and a constant shape. Liquid has a constant volume, but a variable shape. And then when you get to a gas, the gas particles are really spread apart, and they could be this far apart, they can also be more apart, and so their volume's going to change as well. So gases will change volume and shape based on the container. And that's kind of what these slides say. And I know you guys can read, so I'm going to let you read those later. So that's stuff about solid. Now, we can take solid matter and categorize that as well. We can talk about a solid that's crystalline or amorphous. A crystalline solid is going to be like a crystal. It's going to have a long-range repeating order to the particles. So this is a diamond, which is a crystalline solid, and we see there's a definite order to how those carbon atoms are arranged, as opposed to an amorphous solid where they just kind of jumbled together and there's no pattern. It's a little bit like, think about kindergarten, and the teacher calls all the little kindergartners to come up for story time, right? And they plop down on the floor, and they're not sitting in rows, right? But if you have one of those cool rugs with the colored circles, and she says, okay, everybody has to sit on a circle. Well, now the kids are in rows, right? There's an organization to them. So when they're sitting on their circles and they're in order, they're a crystalline solid. And when they're just all over the place, it's amorphous. Amorphous literally means without shape. So that's the summary of the properties of liquids. And this is talking about gases. So one thing that's different about gases that is not common to liquids and solids cannot be compressed. The particles are already pretty much as close together as they can get. And so, if you put them in a piston assembly here and you put pressure on the piston, you can't squish them any closer together because they're already touching, right? There's no extra space. But in a gas, there's a lot of empty space between the particles. And so, it slid over there. I was talking about this one. And so if we put pressure on that, we can squish it closer together. We can compress it. So gases are compressible. So in here, I allude to the student, totally lost it. Students in class can be like solid liquids and gases. So right now, you're sitting in rows, and you're sitting behind her, and you've been that way for like 5 minutes now, right? Nobody's moving around. You're in a solid state. You're pretty close together, and because you're pretty, there's a little amorphousness over there, but most of us is pretty regular here as a crystalline solid. In lab, or when we have a break and everybody stands up and moves around, now you're like a liquid. So you're moving relative to each other, and yet we're still taking up the same volume, right? We're still in the room. We're still close together. We're interacting with each other. And then the gas is like what happens when class is finally over, and I say, okay, you guys can go home, and you go through the door. Some people go that way, and some people go that way, and some people go far, far away, and some people maybe just live down the street, and everybody just spreads out, right? And you probably don't see each other again until Wednesday. It's like a gas. The particles can spread out, and they can also be squeezed back together. Any questions? So that's looking at the state of the matter. We can also look at the composition. And again, I'm going to talk about this slide, and then all those details are written out on the next slides, and I'm not going to read them because that's boring. So here we have matter. So some matter has a variable composition. It's not always the same. Other matter is always the same. So if it's always the same, we say it's not variable, it's a pure substance. So that pure substance, can we break it down into simpler substances? If yes, it's a compound. If no, it's an element. So here we have an example of an element, helium gas. Helium gas always has the same composition. It's just helium atoms. It's always the same. It's not variable. It's the same. Can we take helium atoms and break them down into simpler substances? No, it's like Lego bricks. Can you take a little 2x2 Lego brick and break it into smaller pieces? Not with your hands. Maybe with a saw or something, or a big hammer, and crush it, but that's like a nuclear thing. That's not a chemical reaction, right? Helium atoms are just helium atoms. Okay, so you can't make it any simpler. Here's an example of a compound, water. So a glass of water has water molecules in it, and it doesn't matter where the water came from, all the water molecules are the same. So the composition is not variable, it's always the same. But can we break it into simpler substances? Yes, we can take these molecules and break them apart. It can be as simple as putting a 9-volt battery in the water. The electricity will cause the oxygen and the hydrogen to come apart. And you'll see little bubbles, right? So we can break it down into simpler substances, hydrogen and oxygen. So that's the basis of the difference between an element and a compound. For the variable composition, now this is a mixture. And there are two kinds of mixtures, heterogeneous and homogeneous. And these are prefixes. We use a lot of prefixes and suffixes in the English language, but especially in science. And so if we know what some of those prefixes mean, then we can figure out what the words mean without necessarily needing to memorize things. So homogeneous, homo is a prefix that means the same. So all of the particles in it are similar. It's the same throughout, right? There's not different sections. Heterogeneous, hetero means different. So an example of a heterogeneous mixture would be wet sand. So you can imagine taking a glass of water and putting some sand in it and stirring it up, right? That's all. But then if you wait, all the sand will go to the bottom and the water is at the top. There are two things in there. It's variable composition because you could add more water or you could add more sand, but it's heterogeneous because you can see there's two different things. They don't mix thoroughly. It's chunky. A homogeneous mixture, also called a solution, is when it's the same throughout. So the example here is tea with sugar. So you take a cup of tea, you put sugar in it. Unlike the sand, you could put sand in your tea too. It wouldn't taste very good. It's really gritty in your teeth. It would do the same thing as with the water. You know, you could stir it up, but then it's all going to settle out. But you put sugar in the tea, you stir it up, it dissolves, right? It becomes part of this mixture, and this is the same throughout, even though it has two different things in it. And the composition's variable, because you could put more sugar in, right? The composition's not always the same. Well, how many, is it one lump of sugar or two? But it's going to be just as sweet at the top as it is at the bottom. Whereas a mixture of water and sand is going to be much sandier at the bottom, and there's not going to be any sand at the top. Okay? So there it is in words. Pure substance versus mixture. We've got elements and compounds under pure substances. Here's sort of definitions of those words. An element is something that cannot be chemically broken down into simpler substances. A compound is a substance composed of two or more elements in a fixed proportion. It's a definite, the composition's always the same. That's what makes it a pure substance instead of a mixture. Mixtures can be heterogeneous or homogeneous, and the difference here is how uniformly they mix. So, we should be able to answer a question like this. In this images, a blue circle represents an atom of one type of element, and a red square represents an atom of a second type of element. Which image is a pure substance? It's A. So all of these have red squares and blue circles. But here, every blue circle is connected to a red square. They're all paired up like that. Here, we have blue circles and red squares, and they're kind of all jumbled together. So this would not be a pure substance, this would be a mixture. Would this be homogeneous or heterogeneous? Well, it kind of depends. There's not a real definite line between those, like everything is sort of a continuum. But if we compare this one to this one is more heterogeneous, this one's more homogeneous. Because here all the blue circles are on top and all the red squares are on the bottom, and here they're mixed around more uniformly. Okay, so those are the ideas behind those classifications. Mixtures can be separated because those different components are going to have different properties. So if you think about that glass of water with sand in it, how could you separate the sand from the water? Blow dry it, yeah? Might take a while, but you could heat it and cause all the water to evaporate, right? What's another way? Filtration. So if you pour the sandy water through a coffee filter, the water will go through, right? And the sand will get stuck in the coffee filter. So that's another way. So there are techniques that exploit those differences. So the difference we're exploiting there is that one's a liquid and one's a solid. And so filtration can be used to separate them. Another thing you can do is what's called decanting. And we'll talk more about that in lab. But that's where you take the glass of sandy water and you let it settle, and then you just carefully pour the water off. And so you can get the water off by itself. Now there's still going to be some water in the sand, but you've largely separated that, right? Distillation is a way that we can separate a homogeneous mixture of liquids. So say you have water and ethanol mixed together. How can you separate them? Well, you can't filter it because they're both liquids. But alcohol has a lower boiling point than water. And so if you heat it, the thing with the lower boiling point will boil first. It boils, it goes into the gas state. And so what happens, oops, that's not what I want to do. In this old-fashioned, very simple distillation apparatus here, you've got your mixture and you heat it up. And so say we've got alcohol and water. The alcohol is going to go into the gas state. And if we don't do anything, it's just going to float away, but maybe we want to keep the alcohol. So we have a stopper here, and we're going to run that gas through what's called a condenser. This is a double-walled tube that we can run cold water through. So when you take that gas and you cool it down, it condenses into a liquid. So it's colder here, so it becomes a liquid, and then it drips down here. And so we can get the alcohol over here and the water left behind here. And this is the exact process that's happening when they distill spirits. So, if you're making moonshine or something, this is what they were doing. You get this whole mash of stuff and it's fermenting, and then you're like, okay, well, I want to separate the alcohol. That's the stuff I want from all this other gunk. Is distillation. This is filtration. Solid and liquid can be separated that way. We do this a lot in the kitchen. You're making coffee, or you made spaghetti or boiled vegetables, and you want to get the water out. You put it in a colander, right? It has holes that are big enough for the water to go through, but not for the spaghetti to go through.